+1. What might be a better structure to alleviate the possible formal charge on the phosphorus? What if instead we took this pair of electrons on the oxygen and brought them in down here to create a double bond? Expand the octet on phosphorus. This oxygen that had a formal charge of -1, this phosphorus had a formal charge of a +1. What could we do then to alleviate the possibility of having these formal charges? Well, that answer is, instead of having a lone pair, bring it down to the center and create a double bond. And here's what's happened. Oxygen, who lives in group 6A, now, now has 1, 2, 3, 4, and in this double bond, 5, 6. We've reduced its formal charge down to 0. Phosphorus lives in group 5A. It now has 1, 2, 3, 4, 5 electrons assigned to it, each one of the halves of a bond. We've reduced this down to a 0. Drawing a double bond north, single bonds in the other opposite directions, now created a structure that instead of having a -1 and a +1 formal charge, now they both have 0. We were encouraged to do that, to expand the octet, to bring the formal charge of phosphorus to 0 and the oxygen also down to 0. Here's a structure where selenium ended up to have a +1 and the oxygen up north had a charge of a -1. What could we do to move these electrons around to alleviate the formal charge? Again, suppose I take a non-bonded pair of electrons and move them to the center to create a double bond. And we do so by expanding the octet. And when we've done that, here's what's happened. Selenium, who lives in group 6A, now has 1, 2, 3, 4, 5, 6 electrons assigned to it. We dropped it from a +1 down to a formal charge of 0. The oxygen had a -1. 1, 2, 3, 4, and half of the double, 5 and 6, brought this formal charge down to 0. By adding a double bond, removing a lone non-bonded pair, and bringing it in to create a double bond, we brought the compound down to formal charges of 0, a much better structure. And the same could be true for sulfite. Bring an electron pair in and create a spot where those electrons then can share and bring the formal charge down to 0. And this is the slide where they showed our work. Here, this structure alleviated a formal charge on one of the oxygens. Here, our structure, by creating a double bond, alleviated the formal charge on phosphorus. Here, we decided by bringing in a double bond, we alleviated the charge on selenium. When there is more than one possible correct drawing, we talk about resonance, and that's what these double arrows are showing. If the double bond in sulfite went to the left, it could equally be drawn up to the right or equally drawn to the top. So the location of the double bond could be found in one of 3 places. There are 3 equal resonance structures. True picture is it's not quite a single, not quite a double in any of those directions. It's a hybrid of a single double bond.